Assalamualaikum. We are from group 3. So today we are going to present about the assignment of NDT testing on product and analysis of defect. So for our project, we use leftover injection molding. So this is our group members. Start from the left is Muhammad Amirul Hakimi bin Mahmud, and then Muhammad Azri Haziq bin Abdul Aziz, and me myself, Muhammad Ahmad Fahmi bin Armi. Then Taneshwaran, anak lelaki Balu. And last one, Muhammad Ikhwan bin Zahurin. For our assignment, we are using ultrasonic testing. So why ultrasonic testing? First, height sensitivity and resolution. Ultrasonic testing can detect minor material fault. It also can detect microscopic cracks, voids, inclusion, and discontinuities by sending high-frequency sound wave into the test object and analyzing the reflected wave. This high sensitivity detects possible flaws early, improving component safety and dependability. Second, sonic ultrawave can penetrate deep into material to evaluate surface and beneath flaws. This makes ultrasonic testing ideal for evaluating dense and layered structure. In industry like aircraft, oil and gas, and construction, hidden defects can have serious implications. And third, quantitative analysis. Ultrasonic testing offers quantitative data regarding investigated material, allowing exact defect measures such length, depth, and orientation. This quantitative analysis accurately characterize defect and help determine component acceptability or repair. For quality control and material characterization, ultrasonic testing can measure thickness, density, and acoustic impedance. Next, for ultrasonic testing, what is possible defect that we can know? So first, crack. Surface and subsurface crack can be detected by ultrasonic testing. Cracks from manufacturing faults, stress, fatigue, or other causes can weaken materials' structure integrity. Second, corrosion and erosion. Ultrasonic wave can detect cavities, gas pockets, and inclusion in material. This fault may occur during manufacture, such as insufficient welding fusion, or they may be inherent to the material. Voids and inclusion can weaken and fail the material. Third, thickness variation. Ultrasonic testing accurately measure thickness variation, manufacturing fault, or material degradation, such as thinning due to the corrosion or erosion, can cause thickness difference. Maintaining component structural integrity require monitoring thickness. And the last one, discontinuities. Ultrasonic testing is widely used for checking castings to discover defects like as porosity, shrinkage, or inclusion. Ultrasonic also can be used to identify discontinuities in casting. Because of the potential for these discontinuities to influence the casting mechanical qualities, additional examination on repair or repair work may be necessary.
Okay, my name is Mama Ikhwan bin Zahurin, and right now I will explain about planning, selecting and planning non-destructive testing method. Firstly, about material selection. We choose this material because of this workpiece is small insert. And secondly, surface of every side is suitable for this experiment. The third material of the workpiece is aluminium. On the fourth, size of the workpiece is good enough to complete this experiment. Okay, right now we move to three types of considerable entity. The firstly is ultrasonic testing. Second, radiographic testing, and the third is liquid penetrant testing. We choose ultrasonic testing because of why? Firstly, it is a high sensitivity. First, high sensitivity can detect the defect more clearly because of workpiece length can put into system. Second, ultrasonic can detect the defect between end to end of the workpiece. After that, for versatility, firstly, the inspection technique can be applied to wide range of materials. And second, standard operation procedure of ultrasonic also give short time to apply it. And lastly, depth of penetration. Firstly, ultrasonic can penetrate deep into the material being inspected. And then ultrasonic also useful for inspecting critical components or structures where defects can be present at various steps.
Assalamualaikum, my name is Muhammad Azrazi Ibn Aziz. I'm going to present the methodology, meaning that how the non-destructive test is conducted. In this case, we are using ultrasonic testing for this assignment. First of all, after we find our test material, we have to prepare it. The surface of the test subject must be cleaned off. Make sure there's no foreign object in between our transducer and the test material. To ensure a good contact, we are using a gel as a coupling agent to improve the transmission waves. Second is the calibration. Calibrate using a known reference standards with known properties. Also to ensure the measurement and interpretation of the test result. Third, sound wave regeneration. While the transducer is placed on the surface of the test object, a short pulse of a high frequency wave is generated. The sound waves travel to a material being tested. For setting up the test, in this case, we have to use a piece of paper to put between our transducer and the our test material, so that to make it easy for us to mark it at the end of the test, so you can pinpoint it, the size and the exact location of the defect later on. The fifth one is sound wave propagation. The sound waves travel through material until they encounter a change in acoustic impedance, such as the boundary between a material of an internal flaw. When the sound wave encounter flaw, such as crack, void, and any other defects in the internal defects, or some waves are reflected towards the transducer, meaning that the waves they come early, they do not hit the back wall of the material. So for the monitor, there will be a little bit of tiny spikes that indicates that there is a defect. Next is reception analysis. The transducer now acts as a receiver and detects reflected sound waves, measures the time it takes for the waves to travel the floor and back, notes an echo. It calculates the distance to the floor based on the speed of sound material. The amplitude of the reflected waves also can provide information about the size and nature of the floor. The last and not least is interpretation. After we collected our data, after the test we conducted, we have to record it. We have to pinpoint with exactly the size, the exact location of the defect, and also the nature of any flaws or anomalies within the material being tested. For our cases, we mark using a piece of paper to mark self-finding.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Amir Kimi bin Mahmud. So today I would like to present about the cause of the defect in defect analysis. So the first cause of the defect is the improper material handling. As we know, material are not handled properly can be easy to damage or deform, which can lead to the thickness variation. For example, if the material are dropped, they can become misshapen and have uneven thickness. For our specimen is made from the aluminium, so it is very ductile and easy to misshapen when it's dropped. Second is inadequate tooling. So inadequate tooling defect is a type of the manufacturing defect that occur when the tools used to create a product are not up to the required standard. This can lead to the variety of problems such as poor fit and finish, incorrect dimension, and even safety hazard. This can happen if they are not properly manufactured and if they are not properly maintained. This leads to the tool not to upspan with the force and can damage the product. So we go to the third cause of the defect, which is the improper material selection. Using the wrong material for the application can lead to discontinuities. For example, using a material that are too brittle or too soft can make it more likely to crack and deform. It is very crucial to select a proper material in such a process to avoid the defect, such as discontinuities. In this case, our product is made from the aluminium is because of what it's easy to form the shape that we desired. So the lastly is the improper manufacturing process. Improper manufacturing process can also to lead the discontinuities or crack. This can include things like using the wrong welding technique, poor heat control, or not using the right material. In this case, the product was intentionally built with a pocket in order to fully functioning for injection molding process. So this case, our specimen is built with a pocket, so it can do the function injection molding process.
Good evening, my name is Taneeswaran and I'm here today to present some important details regarding two common defects found in manufacturing processes, which is variation in thickness and material discontinuities. Now let's discuss the potential failures that may occur as a result of these defects and the corresponding material testing techniques that can help mitigate these failures. Firstly, the defect of cracks can lead to fracture failures, ultimately resulting in structural collapse. To detect cracks, both non-destructive testing methods such as ultrasonic testing and magnetic particle inspection, as well as destructive testing techniques like tensile testing and fracture toughness testing can be employed. Secondly, corrosion and erosion are defects that can cause significant material degradation and gradual material loss respectively. These failures can occur due to environmental factors or improper maintenance. Material testing techniques including corrosion testing, erosion testing, and fracture analysis can be utilized to understand the impact of these defects on failure. Next, we have the defect of thickness variation, which can cause localized deformation and stress concentration leading to premature failure. To address this defect, material testing techniques such as thickness measurements, ultrasonic testing, fracture analysis, and finite element analysis, which is we call FEA, can be employed to assess and analyze the variation in thickness and their potential impact on the overall strength and integrity of the product. Finally, the defect of discontinuities can result in fracture failures due to the stress concentration around these irregularities. To detect discontinuities, a combination of non-destructive testing methods such as visual inspection, ultrasonic testing, and radiographic, as well as destructive testing techniques like tensile testing, bend testing, and fracture analysis can be employed to identify and analyze the presence or severity of these defects. In conclusion, by understanding the causes and potential failures associated with the defects such as variation in thickness and material discontinuities, we can implement appropriate material testing techniques to detect and address these issues proactively. This will ultimately contribute to enhancing the quality and reliability of our manufacturing process and products. Thank you.